There is a question so old it predates science itself. It predates philosophy. It may have been the very first question a human being ever looked up at the night sky and whispered into the dark. Are we alone? Not alone in the room, not alone in the city, alone in the universe. That vast, almost incomprehensibly large expanse of space and time that stretches in every direction, farther than any number you were ever taught in school could meaningfully capture. We're talking about a universe with more stars than there are grains of sand on every beach on Earth. Every single one of those stars a sun, many of them with worlds orbiting around them. And yet, as far as we can confirm, life, thinking, breathing, wondering life, exists in exactly one place, here. That fact should feel stranger than it does. We've grown so comfortable with it that we forget to be disturbed by it, but sit with it for a moment. One planet, one pale, fragile rock circling one average star in one unremarkable corner of a galaxy that itself contains hundreds of billions of stars. And from all of that, silence. Or at least no confirmed answer yet. This question has driven people to the edges of reason throughout history. Ancient civilizations didn't just wonder about it, they built entire cosmologies around it. The Greeks debated whether other worlds existed and whether they might be inhabited. Giordano Bruno was burned at the stake in 1600, partly for insisting that the stars were other suns with other worlds around them. People have looked at unexplained lights in the sky and wanted desperately for them to mean something, because the alternative, that we are utterly alone in all of this, carries a weight that's hard to carry. And here's what's interesting. The obsession has never really been about little green men. Beneath the pop culture and the science fiction and the conspiracy theories, the real question is something far more profound. It's a question about the nature of life itself, about whether what happened here, this improbable chain of chemistry and time and luck, is a fluke so rare it will never repeat, or whether life is something the universe does naturally, almost inevitably, given the right conditions. That question changes everything. The answer changes what it means to be human. And what makes this moment in history genuinely remarkable is that, for the first time, we're not just asking the question in the dark. We actually have tools. We have telescopes that can detect the chemical fingerprints of distant atmospheres. We have rovers crawling across Mars. We have scientists who spend their careers listening, searching, analyzing, and who have become far more careful and far more specific about what they mean when they use the word alien. Because that word, it turns out, covers a much wider range of possibilities than most people realize. Before we go any further, we need to clear something up, because the word alien carries a lot of baggage. When most people hear it, they picture something specific. Large eyes, thin limbs, a ship cutting through the clouds. That image is so embedded in our culture that it quietly shapes the question before we even start asking it. And that's a problem because scientists are almost never talking about that when they use the word. What researchers actually mean is far stranger and in some ways far more interesting. When an astrobiologist says life, she means something precise, a system that takes in energy, processes it, and uses that energy to maintain itself and reproduce. That's it. No nervous system required. No face, no desire. Life in the scientific sense is closer to a process than a thing. It's a pattern that resists falling apart. And by that definition, a bacterium living inside a volcanic vent at the bottom of the ocean qualifies just as much as you do. This is why the search for alien life isn't primarily about finding someone to talk to. It's about finding evidence that chemistry, under the right conditions, crosses a threshold, that it stops being dead matter and starts being something that wants to persist. Even a fossilized microbe on Mars would be one of the most important discoveries in human history. Not because it's impressive, because it would prove the threshold can be crossed twice. There's a spectrum here that scientists think about constantly. On one end, you have simple microbial life, the kind that might be hiding beneath the ice of Europa or drifting in the clouds of Venus. On the other end, you have what they call complex or intelligent life, civilizations, technologies, signals. Most researchers consider microbial life vastly more likely. The jump from alive to aware took billions of years on Earth, and it may be the rarest leap in the universe. But here's the part people rarely sit with. Even if alien life is only microbial, it wouldn't be simple. Life on Earth that we once called primitive turned out to be extraordinarily sophisticated at the molecular level. The machinery inside a single bacterium is more intricate than most human-built systems. So when scientists talk about simple life elsewhere, they're using the word carefully. They mean simple in structure, not in significance. What this means is that the real question isn't the dramatic one movies ask. It's quieter and somehow more unsettling, not, are they out there watching us? But did the spark happen more than once? And to understand why that question hits differently when you look at the actual numbers, well, that's exactly where we're going next. Let's talk about numbers for a moment. Not the kind that make your eyes glaze over, the kind that genuinely break something in your brain if you sit with them long enough. There are roughly 400 billion stars in the Milky Way alone. That's our galaxy, just ours. And when astronomers started scanning the skies for planets orbiting those stars, they expected to find some. What they didn't expect was to find them basically everywhere. The data coming back from missions like Kepler suggested that most stars, most of them, have at least one planet. Do that math and you're already looking at hundreds of billions of worlds in a single galaxy before you've even asked whether any of them are the right distance from their star, the right size, the right temperature. Now, step back further. There are an estimated 2 trillion galaxies in the observable universe, 2 trillion, each one containing hundreds of billions of stars. Each star likely hosting planets. The number of worlds out there is so large it has no intuitive meaning anymore. It stops being a number and becomes something closer to a philosophical condition. Here's where it gets harder to dismiss. Of all those worlds, scientists estimate that somewhere between 40 billion and 100 billion in our galaxy alone sit inside what's called the habitable zone. Not too hot, not too cold. The region where liquid water could theoretically exist on the surface. And liquid water, as we'll get to, is not an arbitrary criterion. It matters enormously. So when you stack all of that together, the sheer scale, the frequency of planets, the staggering count of potentially habitable environments, the question quietly shifts. It stops being, could life exist somewhere else? And becomes something more unsettling. Given all of this, what would it actually take for Earth to be the only place it ever happened? That question has no comfortable answer. And it gets harder to ignore once you realize that the raw ingredients life needs aren't rare at all. They're scattered across the cosmos in quantities that should make your assumptions about life feel very, very small. So we've sat with those numbers, the sheer weight of them, the vertigo of realizing how many chances the universe has had to produce something like us, or something nothing like us at all. But here's where the story takes a turn that most people don't expect. It's not just about quantity, it's about chemistry. For a long time, scientists assumed life was fragile, a rare accident, a cosmic lottery won once, here on this small wet rock under very specific conditions. The assumption was that life needed the universe to get almost everything right. The right distance from the right kind of star, the right mix of gases, liquid water, and exactly the right window of temperature. Miss any one of those and nothing happens, life stays theoretical. Then we started looking closer, and what we found changed the conversation entirely. The building blocks of life, amino acids, the organic molecules that serve as life's raw materials, aren't rare. They're not hiding on one special planet guarded by perfect conditions. They're scattered across the cosmos like dust after a storm. We've found them in meteorites. We've detected complex organic molecules drifting through interstellar space, floating between stars and clouds that have never touched a planet's surface. In 2003, scientists found glycine, an amino acid fundamental to protein formation, in a comet. A comet, a frozen rock hurtling through the void, carrying the same chemistry that runs through your own cells. This matters more than it sounds, because it means the universe isn't neutral about life. It's been running the same chemistry experiments everywhere for billions of years on an almost incomprehensible scale. The ingredients aren't scarce, they're the default. And then there's water, We used to think liquid water was exceptional, Earth was the lucky one. But in the decades since we started exploring our own solar system seriously, we've had to revise that assumption almost embarrassingly fast. Europa, one of Jupiter's moons, has a liquid ocean beneath its ice shell, and that ocean may contain more water than all of Earth's oceans combined. Enceladus, a moon of Saturn, is actively shooting geysers of water vapor into space. We don't have to guess about that one. We've flown a spacecraft through those plumes. We've tasted it. And beneath the Martian surface, radar signals have revealed what appears to be a subglacial lake sitting in the dark, insulated from the cold. Water, it turns out, is almost as common as the story we told ourselves it wasn't. But here's the part that genuinely unsettles the old assumptions. Life on Earth doesn't wait for ideal conditions. It doesn't politely require warmth and sunlight and gentle breezes. It thrives in places that should, by any reasonable expectation, be dead. Deep-sea hydrothermal vents where the pressure would crush a submarine and the water is hot enough to dissolve metal. Life is there, dense and diverse, running entirely on chemical energy, having never once needed the sun. Acidic lakes with pH levels close to battery acid, the frozen deserts of Antarctica, the interiors of nuclear reactors. We call these organisms extremophiles, but that name says more about our limitations than theirs. From their perspective, we're the ones living in extreme conditions. Every time we have expanded our definition of where life can exist, we found life already there, waiting. What this does, when you hold it all together, is shift the burden of the argument. The question is no longer whether the universe could support life elsewhere. The chemistry is there, the water is there, the environments are there, far more of them than we imagined. The question has quietly, irreversibly become something harder, something that doesn't resolve as neatly. If the ingredients are everywhere and the conditions are far more flexible than we once believed, and the universe has had billions of years to run these experiments across hundreds of billions of galaxies, then where is Earth, is everybody? So here's where it gets genuinely unsettling. We've just established that the raw materials for life aren't rare. They're scattered across the galaxy like seeds on wind. The chemistry works, the conditions repeat. By any reasonable calculation, the universe should be teeming, absolutely overflowing, with life at various stages of development. Some primitive, some complex, and statistically, some so far ahead of us that the gap would make our entire civilization look like a faint pencil mark on the first page of a very long book. And yet, silence. Not a whisper, not a signal, not a trace. Decades of scanning the sky with increasingly powerful instruments, and nothing has come back except the hiss of background radiation and our own reflected noise. Enrico Fermi noticed this contradiction over lunch in 1950, and he asked it in the simplest possible way: where is everybody? That question became famous precisely because it has no easy answer. We call it the Fermi paradox. And the more seriously you take it, the more it presses on you like something heavy in your chest. Think about the numbers for a moment. Our galaxy alone contains somewhere between 200 and 400 billion stars. A significant portion of those stars have planets. A significant portion of those planets sit in the zones where liquid water can exist. Even if only a tiny fraction of those worlds developed life, and only a tiny fraction of that life became intelligent, and only a tiny fraction of that became technologically capable, you still end up with numbers in the thousands, possibly millions of civilizations that should exist or should have existed. The math practically demands company. And the universe is old, 13.8 billion years old. Civilizations had billions of years of head start on us. So where are the signals? Where are the megastructures, the probes, the artifacts drifting through interstellar space? Where is the evidence of a civilization that had 10 million years longer than us to spread, to build, to make its presence known across the cosmos? Nothing. Some researchers point to the sheer distances involved and say, maybe they simply can't reach us. Space is incomprehensibly vast, and even at speeds we can barely imagine, crossing between stars takes enormous time. But that argument has a weakness. A civilization only needs to send self-replicating probes, Machines that travel to a nearby star use local materials to build copies of themselves and send those copies onward, and within a few million years, the entire galaxy gets explored. A few million years sounds like forever to us. In cosmic terms, it's barely an afternoon. Others suggest we're not listening correctly. Maybe the signals are there and we're just tuned to the wrong frequency, looking with the wrong instruments, too primitive in our technology to even recognize what contact would look like. That's a more comforting thought. But it doesn't fully hold either, because the silence isn't only in our radio telescopes, it's in the optical surveys, the infrared scans, the observations of stellar behavior. If a civilization was harvesting the energy of an entire star, we'd see the heat signature. We've looked, nothing matches. There's another possibility that sits heavier than the others, the one sometimes called the Great Filter. The idea is that somewhere between simple chemistry and a civilization capable of crossing the stars, there is a barrier, something that almost nothing gets through. A step so difficult, so catastrophic, so improbable, that the galaxy is littered with starts that never became finishes. The terrifying question is whether that filter is behind us or ahead of us. If it's behind us, if the hard part was getting from molecules to complex life or from simple cells to intelligent creatures, then we might be genuinely rare, a lucky anomaly, and the silence makes sense. But if the filter is ahead, if it's something that eventually catches every civilization that reaches our level, then the silence isn't an absence of others. It's a warning, and we're approaching whatever it is right now. Scientists debate this with more unease than they usually admit in public, because none of the comfortable answers fully close the case. Every solution to the paradox either makes us special in a way that feels improbable or makes the future dark in a way that feels unbearable. And the paradox doesn't care which one we prefer. What's striking is that we've been having this conversation as though the only question is why we don't see them. But some researchers are starting to ask a different kind of question, one that doesn't start with the telescope, one that starts with what we might be assuming wrong about the nature of intelligence itself, and about what a civilization that survived might actually look like. That's where this gets stranger. Because the explanations that the mainstream tends to avoid, the ones that sound too uncomfortable to say at a scientific conference with a straight face, those might be the ones that finally make the silence make sense. We've been talking about the silence. The vast, almost insulting silence of a universe that by every statistical measure should be teeming with voices. And scientists have spent decades constructing careful, respectable explanations for it. The Great Filter, rare earth, radio signals we simply haven't aimed our antennas at yet. These are the answers that fit comfortably inside a conference room, the ones you can publish without risking your career. But there's another layer of this conversation, one that happens in hallways, not auditoriums, over coffee, not in peer-reviewed papers. And it involves explanations that serious researchers, people with PhDs and tenured positions and everything to lose, entertain privately but rarely say with a microphone in their hand. So let's say it for them. The first one sounds almost too simple, which is exactly why it unsettles people. What if we are not equipped to recognize contact when it happens? Not because aliens are hiding, but because we are, in the most profound sense, cognitively unprepared for what they might look like. We've been searching for radio waves because we use radio waves. We've been imagining civilizations because we are a civilization, but a species that has existed for 1 billion years longer than us might have moved so far beyond anything we recognize as technology, as communication, as life, that we are essentially bacteria looking for hospitals. We wouldn't know what to look for. We wouldn't even know we were looking in the wrong direction. The silence in this reading isn't absence, it's incomprehension. Then there's the one that tends to make people shift uncomfortably in their seats, the simulation hypothesis, not as a late-night dorm room thought experiment, but as a genuine explanatory framework for the Fermi paradox. If our reality is a computational construct, the absence of alien life might not be a cosmic fact. It might be a rendering choice, a boundary condition. Life appears here because this region of the simulation requires it. Elsewhere, the code simply doesn't run that process. It sounds like science fiction until you realize that several physicists, people who calculate for a living, take seriously the possibility that the math of our universe behaves more like software than substance. And then there's the explanation that lives closest to the edge. The one where the question isn't where aliens are, but whether the distinction between out there and already here is as clear as we assume. Not little green men landing on the White House lawn, something subtler and, in many ways, stranger. There is a documented history, documented, not speculated, of phenomena that don't fit our models. Objects tracked by military radar accelerating in ways that violate known physics. Encounters reported not by fringe communities but by naval pilots, commercial airline crews, astronauts. The mainstream scientific response has historically been to look away, not to disprove, to look away. And the question worth asking is why an institution devoted to curiosity would choose, repeatedly and deliberately, not to look. None of these explanations are comfortable. They all require us to loosen our grip on something we prefer to hold tightly, our sense of what's possible, our trust in our own perceptions, our belief that if something were truly here, someone official would have told us by now. But here's the thread connecting all of them. Every single one suggests that the answer to the Fermi paradox might not be out in deep space. It might be right at the edge of what we're willing to examine. Which raises an obvious and somewhat urgent question: what have we actually seen? What evidence already exists sitting in plain sight that we've collectively decided to file under unexplained and move on from? That's exactly where we're going next. There's a peculiar thing that happens in science. Evidence accumulates quietly, patiently in journals and databases and declassified documents, and then nothing happens. Not because the evidence is weak, but because no one with authority decides it's time to take it seriously, and so it sits, waiting. Let's talk about what's actually there. In 2017, Harvard astronomer Avi Loeb watched something pass through our solar system that defied every category we had. Oumuamua, the first confirmed interstellar object ever detected, moved in ways that comets don't. It accelerated as it left the sun, not slowing down the way gravity demands, but speeding up with no visible tail, no gas release, no obvious explanation. Most scientists called it a rock and moved on. Loeb looked at the data and said the most honest thing an astronomer could say: "We don't know what this is, and we should stop pretending we do." His peers largely stopped inviting him to certain conversations after that. Then there's the radio signal. 1977, Ohio State University's Big Ear telescope. A volunteer named Jerry Amin was scanning through printed data when he circled a sequence and wrote one word in the margin: "Wow." The signal lasted exactly 72 seconds, the maximum the telescope could track, and it came from the direction of Sagittarius. It matched almost perfectly what scientists had theoretically predicted a deliberate alien transmission would look like. Narrowband at the hydrogen frequency, the universal wavelength. It has never been detected again, and we have spent remarkably little time trying to find it. These aren't fringe cases. The Pentagon's own UAP task force released footage in 2020 that Navy pilots had been trying to report for years. Objects moving at speeds and with maneuverability that our physics simply cannot account for. No wings, no exhaust. Right-angle turns at hypersonic velocity. The official response wasn't excitement. It was measured, bureaucratic, almost deliberately underwhelming. We are investigating. That's it. The phosphone detection on Venus in 2020 hit like a thunderclap. Phosphine shouldn't exist in Venus's atmosphere without a biological source. That's not speculation, that's chemistry. The announcement came from serious researchers at serious institutions. Within weeks, the conversation had quietly collapsed into methodological disputes about telescope calibration. Maybe the signal was real, maybe it wasn't, but what's striking isn't the uncertainty. Science lives in uncertainty. What's striking is how fast the momentum died. how quickly everyone seemed relieved to move on. And then there's water. Mars had oceans. Europa has a liquid ocean beneath its frozen shell right now, today, larger than all of Earth's oceans combined. Enceladus is actively venting water vapor into space from cracks in its surface. We found amino acids, the building blocks of life, inside meteorites. We found organic molecules drifting in interstellar clouds. The universe, it turns out, is soaking in the ingredients everywhere we look. None of this proves alien life exists. But here's what it does prove. The prior assumption that life is a bizarre cosmic accident that happened once, here on this one pale blue dot, is the least scientific position available to us. The evidence doesn't scream certainty, it whispers something far more unsettling, that we are almost certainly not alone, and that we've been collecting proof of that for decades while treating it like background noise. The question worth sitting with isn't whether the evidence is real. Most of it is documented, peer-reviewed, or caught on government sensors. The real question, the one that leads directly to what comes next, is why the people and institutions with the most resources to investigate it consistently choose not to. Why silence at every level seems to be the preferred response. And whether that silence is really about ignorance or about something else entirely. There's a question that sounds almost too simple. If we already have anomalies, unexplained signals, and serious scientists willing to go on record, why isn't this the biggest story on the planet? The answer isn't as mysterious as people want it to be. It's actually much colder than that. Think about what a genuine, confirmed announcement of extraterrestrial life would do to the world, not in some abstract philosophical way, but in the very concrete mechanics of how societies run. Every major religion would face an existential crisis of interpretation. Every government that has ever claimed to hold the full truth about humanity's place in the universe would face a credibility collapse overnight. Financial markets, which run on stability and predictability above all else, would enter a period of chaos that no institution could fully model or control. These aren't hypothetical concerns. These are the exact scenarios that analysts inside intelligence agencies and policy think tanks have actually studied. In 1960, a commissioned report called the Brookings Report, prepared for NASA, explicitly raised the possibility that announcing confirmed contact with an extraterrestrial civilization might be so destabilizing that it would need to be carefully managed, or perhaps not released at all. That wasn't a fringe document. That was a formal study delivered to the United States government at the very dawn of the space age. And it raised the question without answering it, which in many ways is more revealing than any conclusion would have been. Silence in this context isn't conspiracy, it's institutional behavior. Organizations protect themselves. Bureaucracies preserve their own function. A scientist who publicly advocates for serious UFO research doesn't get laughed out of a meeting. They get quietly defunded, passed over for grants, and excluded from the conversations that matter. The mechanism isn't a shadowy cabal in a room. It's something far more mundane. Professional incentive structures that make silence the rational choice. And governments don't even need to actively suppress anything. They simply don't fund it. They don't declassify it with urgency. They let the noise of culture, the ridicule, the science fiction association, the fringe reputation do the work for them. When something is automatically treated as unserious, you never even have to argue against it. There's also the question of what governments actually know versus what they merely suspect, and that distinction matters enormously. Admitting uncertainty at a classified level is not the same as having a secret you're hiding. Many officials may simply not know. And not knowing, while also controlling the systems that could find out, creates its own kind of paralysis. Releasing ambiguous data invites panic without providing answers. That's a public relations nightmare that no administration wants to inherit. So what you get is a sustained, structurally enforced silence, not built on lies but on omission, inertia, and the quiet calculus of institutional self-preservation. Governments don't need to lie about alien life. They just need to never fully commit to looking. But there's a fracture in that silence that has been growing for decades. Because while institutions were staying quiet, individuals were not. Researchers, astronomers, former intelligence officers, people who gave their careers, in some cases their entire lives, to the pursuit of an answer that no official body would sanction. And what they found, and what it cost them, is where this story takes a completely different shape. There's a particular kind of loneliness that comes with dedicating your life to a question no one takes seriously. Not the loneliness of isolation, but the loneliness of obsession. Of sitting at a radio telescope at 3 in the morning, listening to static, and genuinely believing that somewhere inside that noise, something is waiting to be heard. Frank Drake understood that feeling better than almost anyone. In 1960, when he pointed a radio telescope at 2 nearby stars and listened for structured signals from space, he wasn't doing it as a stunt. He was doing it because he had done the math, sat with the implications, and arrived at a conclusion he couldn't shake. The universe is too vast, too old, and too generous with the ingredients of life for us to be the only ones here. His experiment, Project Ozma, found nothing, and he kept going anyway. That's the thing about this particular breed of scientist. The null result doesn't break them, it refines them. Drake went on to craft what became one of the most famous equations in scientific history, not because it gives you an answer, but because it forces you to confront the right questions. How many stars form each year? How many carry planets? Of those planets, how many could support life? Of those, how many actually develop it? And then, the question that keeps people up at night, of the civilizations that emerge, how many survive long enough to reach out? The Drake equation is less a calculation and more a mirror. It reflects exactly how much we don't know while insisting the question is worth asking. Jill Tarter spent 35 years asking it professionally. She built the institutional infrastructure that turned the search for extraterrestrial intelligence from a fringe curiosity into a legitimate scientific program. She raised funding when there was none, rebuilt after Congress pulled support, and remained rigorous in the face of a culture that oscillated between ridicule and hysteria. When people asked whether she believed in aliens, she would redirect them with precision. Belief, she'd say, is for things you can't prove. We're looking for evidence. That distinction between faith and method is what kept the work credible when almost nothing else did. Then there was Avi Loeb, a Harvard astrophysicist who in 2017 looked at an object tumbling through our solar system from interstellar space, an object with an unusual shape, an unusual trajectory, an unusual brightness, and did something almost no one in his position was willing to do. He said publicly, clearly, and without retraction, "We cannot rule out that this was artificial, that it might be technology." The backlash from the scientific community was immediate and fierce. Colleagues dismissed him, papers were written to counter him, and Loeb responded by writing a book, founding a research project, and doubling down. Not out of recklessness, but out of what he described as a moral obligation to follow the evidence wherever it leads, even into uncomfortable territory. What unites these people, across decades, across disciplines, across very different personalities, is not certainty. None of them claim to know. What united them was the refusal to treat the question as unworthy of serious attention. Because the size of the question demands it. Because a universe that is 13 billion years old, containing hundreds of billions of galaxies, each with hundreds of billions of stars, many of them older than our own sun, that universe is not a place that yields its secrets to timid inquiry. Carl Sagan put it plainly once, "The absence of evidence is not the evidence of absence." We've been broadcasting into space for barely a century. We've been listening for less than that. We've examined a vanishingly small fraction of the frequencies, the directions, the possible forms a signal might take. The silence, if it is silence, is not proof of emptiness. It might simply be proof of how early we are. And that's what these scientists kept coming back to, the possibility that we are early, that the story hasn't reached its turning point yet, that somewhere in the data we haven't collected, in the frequencies we haven't monitored, in the ocean floor we've barely touched, or the signals we misclassified as interference, there is something waiting, patient, unaware of us or aware and watching or already gone, but there. Which brings us to the question these researchers never fully answered because it was never fully theirs to answer. Not the scientific question of whether life exists out there, but the human question, the civilizational question of what happens to us the moment we find it. Because that discovery, if it comes, wouldn't just change astronomy. It would change everything. And the world has never seriously reckoned with what that actually means. There's a question that scientists almost never ask out loud, not because it's unscientific, but because the answer is too large to fit inside a research paper. What actually happens to us, to civilization, to everything we've built, if the answer turns out to be yes? Not the discovery itself, what comes after. Think about the last time something fundamentally rewrote how you saw the world, a moment that split your life into before and after. Now scale that to 8 billion people simultaneously, with no warning, no shared framework, and no way to go back. That's the minimum version of what contact would mean. Historians have a concept they rarely use in polite company: civilizational shock. It's what happens when a culture encounters something so foreign, so structurally different from everything it knows, that its existing tools for understanding simply stop working. It happened when isolated civilizations first met each other here on Earth. It reshaped languages, religions, economies, and governments. It took generations to stabilize, and those were encounters between humans. Now consider that any civilization capable of reaching us or transmitting a signal across interstellar distances would almost certainly be older than us, not by decades, possibly by millions of years. The gap between their knowledge and ours might be comparable to the gap between a surgeon and a stone tool. And we would know it, that knowledge alone, before a single word was exchanged, would detonate something inside the human sense of self. Religion would not simply collapse. That's too simple. Some traditions would reinterpret everything, finding confirmation where others find contradiction. The fractures would run differently through different communities, and that unevenness would be its own kind of crisis. Politics would convulse around a single question with no clean answer: who speaks for Earth? Not a country, not a treaty organization. Earth. No such institution exists. No such consensus is even close, and science, ironically, might be the most disoriented of all, because science operates by building on what came before, each generation extending the work of the last. Contact would not extend that work. It would potentially render entire fields provisional overnight. Physics, biology, medicine, cosmology, all of it would need to be re-examined against a standard we hadn't known existed. But here's what the catastrophists miss, and what the optimists sometimes oversimplify. Humanity has a strange, stubborn capacity to absorb the unthinkable and keep moving. Not cleanly, not without loss. But we move. Every revolution in understanding, Copernicus, Darwin, Einstein, was supposed to break something irreparable in us. And each time something broke and something else grew in its place. Something that eventually looked from a distance like resilience. The deeper truth is that contact wouldn't just change what we know, it would change what we think knowing even means. The very project of science, the assumption that human minds can, given enough time, understand the universe, would be tested in a way it never has been before. That could be humbling to the point of paralysis, or it could be the most clarifying moment in our species' history. A reminder that we are not the end of the story, just a chapter, maybe an early one. What's strange is that some of the scientists who spent their lives searching understood this better than anyone. They weren't just looking for signals, they were preparing us slowly and quietly for the possibility that the answer would arrive before we were ready. And now, after everything, the equations, the telescopes, the decades of listening, what they found might surprise you in a way that none of this has. Because the truth isn't waiting somewhere out there in the dark, it's considerably closer than that. You have been waiting for a revelation, something enormous, undeniable, a signal that cuts through every doubt and says, you are not alone. And somewhere along the way, you started to imagine what that would look like. A craft descending through clouds, a transmission decoded by scientists in white coats, a press conference that changes everything in a single afternoon. But here is what nobody told you. The truth was never going to arrive that way. The closer researchers look, the more they find something stranger than visitors. They find conditions. Everywhere they look, in the frozen oceans beneath the moons of Jupiter and Saturn, in the methane lakes of Titan, in the thin ancient atmosphere of Mars, they do not find emptiness. They find the ingredients. They find the boundaries where chemistry becomes something more. Life does not need an invitation. It finds the door on its own, and this is where the real surprise lives. For decades, we pointed our telescopes outward, assuming the answer was far. Thousands of light years, another galaxy, something unreachable in principle, almost mythological. But Europa is right here, Enceladus is right here. The plumes of water vapor erupting from its surface are real, and they carry organic molecules into space, molecules that we already know are associated with biology. We are not talking about speculation dressed in science. We are talking about confirmed geysers, confirmed organic chemistry, confirmed liquid water beneath the ice. The distance between those facts and the word life is smaller than it has ever been in human history. There is something else, though, something harder to sit with. If microbial life exists in our own solar system, in places we already have the technology to reach, then the Fermi paradox stops being a cosmic mystery and becomes something more personal. It means the universe was never the empty, silent place we feared. It means we were the ones who weren't looking closely enough. Not because we lacked intelligence, because we were looking for the wrong thing, in the wrong shape, expecting the wrong kind of knock on the door. The truth about alien life is not that it's hiding from us, it's that it has been sitting at the edge of our vision, quiet and patient, while we kept scanning the horizon for something dramatic. A single bacterium floating in a subsurface ocean 80 million kilometers away would be, without exaggeration, the most important discovery in the entire span of human civilization. Not because it answers every question, because it ends the question of whether we are alone, permanently, irrevocably, forever. And we are right now at the exact moment in history when that discovery is not only possible, it is being planned. The missions are funded, the instruments are being built, the trajectories are being calculated, which means this is not a story about something that happened or something that might happen in a vague and distant future. This is a story happening now. And the next chapter does not belong to the scientists alone. There is a moment in every great story where the camera pulls back and you realize you are never just watching, you are always part of it. That moment is now. We stand at the edge of something no generation before us ever stood at. Not because we are smarter or braver or more deserving, but because the tools finally caught up to the questions. The telescopes are powerful enough, the computers are fast enough, the mathematics is sharp enough, and for the first time in the entire history of this species, the answer to "Are we alone?" is not a matter of faith or philosophy, it is a matter of time, and time right now is very short. Within your lifetime, not your children's, not some distant civilizations, the data will arrive. The signals will be analyzed. The atmospheric fingerprints of worlds light years away will either confirm what billions of people have quietly suspected, or they will deepen the mystery in ways we cannot yet imagine. Either outcome changes everything. Either outcome is the most important thing that has ever happened to a human being, and you will be alive for it. That is not a small thing. That is an extraordinary privilege dressed up as ordinary Tuesday news. But here is what most people miss. Discovery is never just a moment, it is a culture. It is the millions of people who stayed curious when cynicism was easier, who kept asking questions when the answers were inconvenient, who refused to let wonder be educated out of them. The scientists working late in quiet observatories are doing their part, and so are you. Every time you choose to understand rather than dismiss, every time you sit with the discomfort of not knowing instead of reaching for a comfortable lie. Curiosity is not passive. It is one of the most radical acts a human being can perform. So when that discovery comes, and it will come, it will not belong only to the people in white coats. It will belong to everyone who looked up, everyone who asked, Everyone who is willing to feel small in the face of something enormous and call that feeling wonder instead of fear. That includes you. You are not a spectator to the greatest chapter in human history. You are inside it right now, in this moment, deciding what kind of person you will be when the universe finally answers back. Stay curious, stay uncomfortable, stay awake. If this journey meant something to you, subscribe to this channel because we are just getting started and you do not want to miss what comes next. Leave a like if this made you think and tell me in the comments, do you believe we are alone? Because I read every single one and that conversation is one I genuinely want to have with you. The universe is vast, but somehow you found your way here. I do not think that is an accident.